So we're continuing on with the comparison between the sine, cosine, tan of obtuse and acute angles. Okay. So we have noticed earlier, as we saw, that the sine for all acute angles and obtuse angles is going to be positive. Sine is positive for acute and obtuse. However, cosine and tan is negative for the obtuse angles, positive for the acute. Okay? So just a quick reminder, acute angles are angles less than 90 degrees. Obtuse angles are between 90 and 180. And then we talked about supplementary angles. They sum up to 180 degrees. Sorry? No. Obtuse angles are between 90 and 180. We don't have angles that add up to 360, like two angles that add up to 360, right? Or an angle that is higher than 180. Okay. In a triangle. Okay, so this is what we call the Cartesian plane. You've seen it before. It's x and y, right? So we know that in the x and y Cartesian plane, we know that this is positive x, positive y, negative x, negative y. Yes? Good. Now, if I want to draw my triangle, and I draw it in the Cartesian plane, right? This is what we do. So we're talking about right angle triangles here, right? So we always draw it from the origin, and then we drop it down to the x-axis. Okay? So this is my triangle here. My triangle here is a right angle triangle. And my angle of interest is always the one that is formed between the x-axis, the positive x-axis, and what we call the terminal arm. Okay? So basically my angle of interest is this angle right here, because that's the angle that is measured between the positive x-axis and the terminal arm. Okay? Now, looking at this angle right there, angle theta, what can you tell me about it? Is it acute or is it obtuse? It's acute, right? It's less than 90. Where is my 90 degree? So between this and this is where my 90 degrees. So any angle in the first quadrant, it's going to be acute, right? Because it's less than 90 degrees. So any angle, no matter what it is, in the first quadrant, it's going to be an acute angle. Do you guys understand that? Are we okay with that? All right. Now, so in quadrant 1, I only have acute angles. Okay? In quadrant 1, only acute angles. Now, what can you tell me about the x and the y in quadrant 1? Are they positive or are they negative? Both are positive. Good. So both x and y are positive in quadrant 1. Now, how about in quadrant 2? So if I draw a triangle in quadrant 2, where did I say we always measure our angle? From where? From the x-axis. From the positive x-axis. We always measure our angle from the positive x-axis to the terminal arm. Okay? So, looking at this angle right here, is it greater than 90 or less than 90? Greater than 90, right? Because the 90 is the green line, right? So in this case, it is greater than 90 if you're looking from the x-axis to that terminal arm. Are we okay with that? So that means angles in the second quadrant are what? Obtuse or acute? Okay.
So the x is going to be the center, like always going to be the center of the...
X is always going to be where you're measuring from.
Just the positive side of
Yeah, you always measure from the positive x value. Okay? So in this case, I have an obtuse angle, right? Now, my question to you, x and y, are they both positive? Which one is positive? Which one is negative?
Y is positive, X is negative.
Y is positive, x is negative, right? So in this quadrant, we have y is positive, x is negative. Now, in this course, we're only going to talk about the first two quadrants, quadrant 1 and quadrant 2, because the only angles that we're going to talk about for now are the angles that go up to 180 degrees. Okay? So I'm going to add a page here, and I'm going to kind of go over the whole ideas with you, all of the ideas. You have a question?
I was just saying, so we don't do the cosine and cotangent.
Not in the third and fourth quadrant. Okay? Okay, so this here is, so this is x, this is y. This here is angle 0 because we always measure from the x-axis. So if it lies on the x-axis, it's going to be 0 degrees, right? This is angle what? Up here. Angle 90. And this is angle 180, right? Because if I'm measuring from here to here, that's going to be 180. It forms a line. Okay? So these are the important these are the important angles that you're looking at, 0, 90, and 180. Okay? If it lies in the first quadrant, it's an acute angle. If it lies in the second quadrant, it's an obtuse angle. Are we okay with this? Good. Now, let's draw a triangle in the first quadrant. So now this is my triangle here. It's a right angle triangle. And this is my angle of interest. Okay? Now, can you guys tell me which one is the opposite, which one is the adjacent, which one is the hypotenuse according to this? So what do we call this line right here? Opposite, adjacent, opposite. Perfect. Excellent. Now, according to angle theta, if I want to do sine theta, what is it going to be? Sine theta is opposite over hypotenuse, right? So if I'm going to take this point right here, this is going to be xy, right? A point in the Cartesian plane is xy. Is both x and y positive, or are they one positive, one negative in the first quadrant? They're both positive, right? We agree on that? Okay. Now, you guys agree that if I drop this, this is going to be my y, right? Because that's the same as this, right? And this is going to be my x. Okay? So think about it this way. I'm gonna draw a Cartesian plane here. So let's say I have a point here at 2, 3. Okay? If I draw my oh my God, this is a very ugly triangle. If I draw my triangle, right, which is this, right here. What's the height of this? It's 3. What's the length of this? 2, right? So they're the same as the point, which is 2, 3, right? So this basically is your y value, and this is your x value, right? I still don't see faces that understand this. If I have a point here, and that And that point is 2, 3. Okay? So if I draw that, so this right here is 2, so that means the x value is 2, and the y value is 3. Right?
Yeah.
Okay. So if you look at this triangle, this here is the same as this, right? These are the same. This is the same as this, right? So that means this is 3. Right? And this is your x value, which is 2. Okay. This is your angle of interest, right? Okay. This is your x value, your y value, sorry. And this is your x value, yes? So if you look at the point, x value is 2, y value is 3. Now, if we're going to look at this, sine of angle theta is what? Opposite over hypotenuse. So it's going to be 3 over whatever that is, right? We have to find that. Okay? So opposite over hypotenuse, right? So in this case, it's going to be y over hypotenuse. Okay? So I just showed you an example, so we can go back here. Now, if I want to do, it's going to be opposite, which is y, over the hypotenuse, which is in this case, I'm going to call r. R, yep. Which is the radius of a circle. We're just going to leave the formula for now. Okay? If I want to do cosine theta, what would it be? What's the formula for cosine? So what's the letter for adjacent in this case? X over r. How about tan? Which is? Good. Now, this is going to be useful to me because then it's going to tell me why they're positive in some cases and why are they negative in other cases. Okay? So let's look here. In the first quadrant, y and x are positive? Both of them? Yes. The radius is going to be positive because the radius is the one that I calculate, and it's the hypotenuse. So it's going to be positive, no matter what. Okay? Because remember that if I want to find the hypotenuse, it's going to be r squared equals to a squared plus b squared, or x squared plus y squared. Right? Because I know what x is, I know what y is, I can find r. Do you want me to do it with that example right there? Let's find r here. Let's find r. How can I find r? So I do r squared equals x squared plus y squared. X is what? X is 2. So 2 squared plus 3 squared, which is 4 plus 9, which is 13. So r is the square root of 13. R is going to be positive no matter what, because when I square, even if they're negative, the x and y, even if the x and y are negative, when I square them, it's going to give me a positive value. Right? Negative 2 squared is? What's negative 2 squared? Positive 4. Negative 3 squared is? Positive 9. So no matter what, they're going to give me a positive number even when I add them. Okay? So the radius is going to always be positive. Okay, let's look here. Y is positive and the radius is positive. That means sine is positive. For cosine, x is positive over r is positive, so it's going to give me positive. Tan, y is positive, x is positive, right? Because they're both in the first quadrant, both x and y are positive, it's going to give me a positive. Okay? That's why in quadrant 1, the acute angles, they're going to be all positive. Now let's look at the obtuse angles. So, my angle of interest, or my angle, is going from the x-axis to the terminal arm. So this is my angle. What can you tell me about this angle, acute or obtuse? Obtuse. Now, I can't form an angle, a triangle here, because technically the triangle is going to look weird if I try to form it with the x-axis. So what I do is I actually use this triangle right here, because they always have to be down to the horizontal line. Okay? So you see that I'm using this triangle on the left side. Angle theta is not part of it, but we know that these two angles are, what do we call them? What do we call this angle right here? And angle theta. Okay, just focus with me for a second. Theta and alpha, if I add them together, what are they going to give me? 180. What do we call two angles that add up to 180? Supplementary angles. So angle theta and angle alpha, they're supplementary angles. Okay? One of them is obtuse. The other one is acute. Okay? Now, because it's in the second quadrant, let's see what is going to happen with the cosine, tan, and sine. So, opposite to the alpha is, so let's say, this is what? Opposite or adjacent or hypotenuse? This is the opposite. And this is the letter y, right? Good. How about this line right here? That's the adjacent. And what letter is it? It's x, right? Because it's on the x-axis. Okay. And this is the hypotenuse, and we call it r. Now, let's look at the sine, cosine, and tan. If I'm going to look at sine theta, sine alpha, sorry, it's going to be opposite over adjacent, right? Which is, sorry, that's wrong. Opposite over hypotenuse. Now, opposite is the value of y over r. Can you guys tell me what y is? What's the value of y? Just 3, right? I don't know what r is, so let's calculate r. R squared equals x squared plus y squared. X is negative 4 squared plus 3 squared. So that's going to be 16 plus 9, which is 25. So that means r is 5. Are we okay with this? Okay. So that's 3 over 5. So sine theta is 3 over 5. Positive over positive is? Positive. Good. Let's look at cosine. So cosine is adjacent over hypotenuse, right? What's the value for the adjacent? What letter is it? X. So x over r. What's the value for x? X is negative 4. What's the value for r? Yeah, we just found it. 5. So, look here. Negative 4 over 5. Is that positive or negative? Negative. Negative. Is that what we expected? Because it's in the second quadrant, it's an obtuse angle, so we're expecting cosine to be negative. And the reason for that is because in the second quadrant, x is negative, right? X is negative in the second quadrant. It causes the cosine to be negative. Now, let's do tan. Tan is, the formula for it is opposite over adjacent, which is, in this case, it's y over x. What's the value of y? 3. What's the value of x? Negative 4. Is that positive or negative? Negative, because positive over negative is negative. Did we expect tan to be negative?
Yes.
Yes, because it's in the second quadrant. So now you know why, for obtuse angles, cosine and tan are negative. However, sine is gonna stay positive, right? Because y is positive in the second quadrant. So, first quadrant, sine, cosine, and tan are positive. In the second quadrant, sine is positive, the other two are negative. Are we okay with that? Okay. So let's go back here. So we know that we're going to only talk about quadrants 1 and 2, right? We basically have quadrant 1, 2, 3, 4. So we're moving counterclockwise, starting from the upper right. So this is called quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We're only going to talk about the upper 2 quadrants. And then basically we just talked about this, right? So I am going to redraw it. So point P is x and y. We talked that if we form a triangle, this is the y, this is the x, and this is r. Sorry? And we said that sine theta is y over r, and it's positive. And we said that cosine theta is x over r, and it's positive. And we said that tan theta is y over x, and it's positive. Anyone have any question about this? Are we okay with the letters x, y, and r? They just picked r. They picked r because r is the radius, and technically this is a circle. Like I can form a circle right here, and the radius goes from the origin to that point. That's why they picked r, but we don't worry about that. Just call it r. If point P is in quadrant 2, then we said that angle theta is an obtuse angle, right? So we did just do that, but I'm going to redo it right here. So x is negative in this case. And then we know that sine. Remember that theta is the one measured from the x-axis. So this is theta, right?
What's that next name? Theta, beta?
Alpha
Okay. And omega.
and beta, we use all of them.